As we take immense pleasure in introducing Dr. Seshadri Ramkumar, he is currently a full professor in Department of Environmental Toxicology at Texas Tech University. His research focus on developing value-added materials using non-woven and nanotechnology. He supervised the nano-woven and advanced material laboratory at we take immense pleasure in Dr. Seshadri Ramkumar is currently a full professor in Department of Environment and Toxicology at Texas Tech University. His focus on developing value-added materials using non-woven and nanotechnology.
Are you able to hear me?
Yes, sir.
Okay, shall I start?
Yes, sir.
Okay. Good afternoon to you all, and it's early morning about very good afternoon, and it's nearly early morning for me in Texas, but it's a pleasure for me to participate in the International Conference on Sustainable Technologies and Circularity organized by SSM College of Engineering, Komarapalayam. I understand that there are participants from prestigious institutions like NC State and from Egypt and elsewhere. The reason for me to get such a relish to participate in this is exactly some 17 years back, in 2006, myself and Cavalier Madhivanan, the chairman of your institution, organized a conference in Coimbatore, one of the first on technical textiles. I'm going to show you the souvenir from that conference. So, Advanced Fibers and Technical Textiles Conference in 2006 in Jenny's Club, Coimbatore. So, we were the first one to bring international organizations such as AATCC, INDA and others to come to Coimbatore to organize this event. So, I'm really thrilled to participate in one such international conferences, even though it's 17 years back. Having said that, I want to acknowledge your chairman of the institution, Dr. Madhivanan, Professor Rajendra Kumar and all others and those who are helping to coordinate this event. So my talk is going to be on sustainable advanced textiles. So why do we need to worry about sustainability, and what is the reason? The industry is moving towards sustainability because sustainability means different things to different people. It can be energy sustainability, it can be material sustainability, it can be labor sustainability, and it can also mean reuse, reinvent, and so on and so forth. Where do we go? Why nations are particularly interested in sustainability? Because United Nations has set a goal called sustainability goal, which has 17 components, and most of the countries would want to comply with those United Nations sustainability goals so that we leave a better world for the future generation. So I'm going to show you one or two examples and also a demonstration how we can develop sustainable products for advanced applications. So advanced textiles are not for simply fiber to fashion. Advanced textiles are, in my opinion, are needed to enhance human health, to improve the lifestyle or the health of the people, and to protect the environment. So within these two main aspects, 12 or different kinds of advanced textiles can be developed. And one important thing we face in the textile industry if you use synthetic fiber is the microfibrillation. So when we are washing these synthetic fabrics in the washing machine, you get these minute microplastics that go into the drain, and they also go into the ocean.
And when they go into the ocean, many sea creatures intake it. And when people are eating these sea creatures, these are found in the human body. particularly in liver and stomach and even in blood and fecal matter. So it's going to be a big health problem. So people are again thinking of switching to sustainable fibers. They can be cotton, they can be blends of cotton with others, they can be flax, they can be hemp, bast fibers, and so on and so forth. So sustainability is a very relevant topic because a lot of issues are coming up and mainstream newspapers are picking up the hazards of microplastics. So if you are using any facial wipe, most of them are polyester based. We are trying to replace them with cotton. So I'm going to show you an example of a cotton based wipe. This is not yet for facial applications. This is a natural cotton with lot of barks and plant material in it. So sustainability means we have to use natural product. At the same time, we are reducing the cost of the raw material. 60 to 70% of a product cost comes from raw material. So I'm going to show you an example as a replacement to synthetic material, replacement to polypropylene material, replacement to polyester. Slowly, we cannot replace 100%, but we are trying to replace. So can we develop advanced textiles? Yes, we can. I have shown you an advanced textile product from raw cotton. The cotton is not given any chemical treatment. So thereby, it is also chemically sustainable. I'm using a natural fiber. So it is fiber-wise sustainable. And I'm going to use this product to protect the environment. How it soaks oil from a clean water, because oil, crude oil over the period of time may lead to carcinoma. So it's carcinogenic. So I'm going to use a natural product which is very sustainable. We have reduced the cost because we are not giving any chemical treatment to this cotton. And we are going to show you in a small demonstration. I have brought the laboratory onto a kitchen table. So I'll show you an example how we can develop oil absorbent natural cotton material which is sustainable, that is going to protect the environment and over the period of time save lives. Okay. And I'm going to, we started this product and this project some 10-12 years back when United States had one of the largest oil spill in Gulf of Mexico. Until then, the Exxon Valdez in Alaska was considered to be the largest spill some 20 years back. But when the Deep Horizon well broke, owned by British Petroleum, it is considered to be one of the largest spill, roughly around 4.25 million barrels of oil, and that caused a lot of problems. So people were looking into sustainable materials. The oil absorbents are predominantly made by synthetic materials. We were one of the earliest one to consider natural cotton to be an alternative to synthetic material. So we are going to show you how we developed oil absorbent. This is a typical oil absorbent from natural fiber. So that's what we are going to show. And this work was done by one of my earlier PhD student, and this work became internationally known. So how we do, we take a natural cotton, and that natural cotton is not fully mature. If the cotton is not fully mature, people in the dyeing industry, particularly in Perundurai and Tirupur, would know if the cotton is not fully mature, it will not have good amount of cellulosics. If it is not having good amount of cellulosics, its dye pickup will be ununiform, and you have to spend a lot of dye to get a uniformity. Once you are using a lot of dye material, it's not sustainable. It may be an environmental pollutant. So what we are doing is we are taking a low microner or immature cotton and developing an advanced product with no bleach, no treatment to it. Even we did not even remove the wax in it. So we don't even use covering or bleaching or dyeing. So you can see this. So we are using a low cost raw material, which is a immature cotton. In otherwise, the industry knows it as low microner cotton. Low microner cotton, people do not use it because it doesn't take dye well. It leads to white specks in denim. So, okay. So why we use low microner cotton? Cotton is a natural product. So when the weather is not congenial, when the weather is very hot during summer in Texas, Texas is the largest cotton producer in India, similar to Gujarat, which is the largest cotton producer in India. So Texas state is the state of Texas is the largest cotton producer, and 1/3 of the total cotton production in the United States comes from Texas, approximately. So when the weather in the summer is very hot, the plant doesn't mature well. So in most of the time, roughly 15 to 20% of the cotton produced If the weather is not good, falls under low microner. So we have to find some new applications for this. Then we use Texas is known for cotton. Texas is known for its animal industry. Texas is known for its crude oil. So Texas is one of the largest producer of crude oil in the United States. So we used the Texas crude. Nobody had tested until then, until our labs put out the results. Nobody have tested the results on a crude oil. Crude oil is highly viscous and it is carcinogen. So this is how we do. People think that raw cotton is more or less similar to the cotton which the doctor used to clean the tissues, to soak up the blood. No, that's totally different. On the left-hand side, you see an absorbent cotton. That is basically cotton wool, which medical practitioners use. And on the right-hand side, to me, marked as raw cotton is a cotton material like this, no treatment. Whereas the absorbent cotton has been scoured and it has been treated with hydrogen peroxide. Not every place can use hydrogen peroxide because you have to get your approval done through regulatory bodies. Okay, so now what is the difference? So people thought that if you could use an absorbent cotton, you can soak up oil. No, absorbent cotton with peroxide bleach will not be able to soak up oil because it will sink. Whereas the natural cotton here will float on the surface, oil will come on the surface. So the cotton that is floating on the surface will bond to the oil. So I'll give you this will be a short video and then I will actually show you the experiment, how it is done. Now watch for a second. On the left-hand side, you have absorbent cotton. It instantaneously sinks in water. If it sinks in water, how will it be able to get the oil? It will not. Whereas the raw cotton, which you see here, is able to float on the surface. Oil is lighter, less denser than water. So people 101 basic chemistry, oil will come to the surface. That's what you see here. Assume that this is a river bed or assume this is a clean water resource and I'm using some oil. This is not a crude oil because we cannot use crude oil. I'm doing this demonstration from my kitchen. So this is a clean water. I'm going to pour some oil into it. Now I'm shaking it. No matter how you shake, the oil and water will not mix. So there will be phase separation. Oil will come to the surface. Now I'm taking this raw cotton with no treatment. You see, it's not even white. I'm just simply putting it on the oil surface. You see that the cotton mat will not sink. Whereas if you use an absorbent white cotton, it will instantaneously sink, as you saw in the video. And then I'm also agitating it. And instantaneously, you could see that the bath is crystal clear. In one soak, I've done nothing, no magic. Just simply the raw cotton picks up the oil. Are you able to see this? You can see now the water bath is clean and the raw cotton soaks up. Again, I am putting it. You can see that it is not sinking. So this is one of the advanced application. Raw cotton, immature cotton is able to find application to save the environment, to soak up the oil. So now I'll show you some results. Microner, lower the microner, the immaturity is more. When the immaturity is more, it cannot be used to develop high fashion fabric. So when the microner value is less, it is highly immature. As the microner value increases, it's a better cotton. So the premium cotton is from 4.3 to 4.6. That's good cotton. So my interest is to show that the low microner cotton or highly immature cotton is able to take up more oil compared to the normal cotton. So let's skip this. So this is actual setup. What I showed you here is using motor oil, which is not as toxic as crude oil. But on the slide, you see the dark black, pitch black tar like it. So that is nothing but the crude oil. So we can't do experiments using crude oil here because you need to have some safety clearance and all. But you can see the same procedure I'm using. Only thing what I'm changing is the type of the oil. Okay. Now I need to show you that low microner cotton, that is the immature cotton like this, is able to absorb more oil. If you look at it, 3.1 is highly immature cotton as against 4.4, which is a good cotton. So each gram of this, now each gram of cotton if its low microner is able to absorb about 36 grams, that means 36 times. 1 gram of cotton will be able to absorb at least 36 grams of oil. Whereas when you compare the high range premium cotton, it will only absorb about 30 grams. Imagine, we are talking about toxic oil. So even 1 gram matters a lot. So we have proven that using a natural cotton with no treatment, get it from the bale, make it as a non-woven. So there again, you are reducing the cost because you are shrinking the manufacturing. We are not weaving into a fabric. We are making a non-woven material. So there again, the sustainability comes because we are saving cost of manufacturing. We are not taking a premium cotton, which is going to be used for high fashion products. We are using an immature cotton. The cotton has natural material in it and it instantaneously soaks up oil better than the absorbent cotton. Now, this cotton has a lot of vegetable matter in it. Vegetable matter is biodegradable. So when you take this, you can use it multiple times, 3 or 4 times, then squeeze the oil. Then you will reclaim the oil, recover the oil, and then throw this into the sand. When you throw this into the ground, the natural material and the oil become food for microbes. So the microbes taking this oil, they will be able to digest. Right? Like cow is able to digest hard material, bacteria and other microbes in the soil will be able to consume this cotton material, which is natural, as well as the oil. The oil gets broken down. When the oil gets broken down, its toxicity decreases and it becomes a natural product. And then the excretia from these microbes become manure. So with the conference is on sustainability, I told you that we are using sustainable material and then circularity. What happens? These microbes consume this cotton, the cotton biodegrades, and whatever the excretia from these microbes becomes natural manure. So it's total 360 circularity. We have shown that raw cotton from the plant can be used to develop advanced product. Developing an oil absorbent as a replacement to a synthetic material is obviously a sustainable advanced product. So what's the mechanism? This is one of the first pictures that shows how this works. So you can see that cotton is basically twisted in nature. So this is a non-woven web and you take a scanning electron microscope. So the oil, you can still see it's not sunk in. The oil is still being soaked. Now if I take this, you can see it's totally crystal clear. I have not done anything. I have not put any chemical. So what happens? The oil first spreads on the mat, which you saw, and not only it spreads on the mat, it goes into the interior portion of the cotton. Cotton in the interior portion of cotton is basically lumen. It's like an hollow space. Low microner cotton has more lumen because the cellulose deposition is less, little bit of chemistry. So not only it takes it as a surface layer, then whatever is in the surface, it slowly drips into the individual fiber. When it drips into the individual fiber, it becomes like a balloon. It becomes like a reservoir. So the cotton is held tight. Then how do you release the oil? You have to put pressure. You have to squeeze it like we are squeezing the towel. After you bath, you squeeze it. So that's known as wringing. So you wring the oil out of the towel and then whatever the oil that is left will be held inside the balloon, so there is no spilling, there is no secondary contamination. Then you take this mat, which has oil left in it, put it in the ground. Over a period of 6 to 8 months, it will totally degrade. So beautiful experiments, and you can see that all the time, whether you do it in a small beaker or whether you do it in a laboratory setup, or you take this. So you take this mat and make it in a big roll and then use it in the sea, it instantaneously soaks up. What is the mechanism? Why this happens? That because natural cotton has wax. How do you remove wax from the cotton? That process is known as covering. It uses sodium hydroxide alkali to knock off the wax. We don't use it. We keep the wax. So there again, we are not using any alkali. We are not using any caustic product. We are not using any chemical. So there is no worry to dump them in Kaveri or somewhere. So there is no worry about environmental pollution. So it's totally sustainable and it is recoverable. The oil is recoverable, and then the cotton, what is left in the ground, degrades within 6 to 8 months, depending upon the nature of the soil and the ambient condition and then other aspects. So it gives to some natural product which can strengthen the soil. So totally what we do, immature cotton, where the cellulose content less, is able to absorb more oil because immature content is known to have little bit extra wax. Wax is oleophobic. Oil and wax are polar interaction. So they both absorb each other. So when you consider wax and oil, they both attract each other. Wax repel water. So that is the reason the cotton is not being soaked in water, it floats. Whereas when you take a terry towel, the cotton that has been treated with sodium hydroxide, you are knocking the wax, so it will already instantaneously sink into the water. Beautiful chemistry. This work has been published in one of the important journals in the field, and because it is sustainability, it gives new application to cotton. It is circular, product is circular, no toxicity involved. It is able to protect the environment because if there is an oil spill, even recently, last month or so, during the floods in Chennai, you could see that one of the petroleum refineries in Chennai, it leaked and there were floods of oil in the Ennur and other North Chennai area. You could see this. So the oil spill happens. When the oil spill happens, it's an environmental threat. And when people consume the oil and water mixed together, it leads to a lot of problems, particularly in young children. So we have developed an advanced material from sustainable product. It is circular and it is able to save the environment and protect children. And because of this total circularity, many international magazines and newspapers picked it up. And we were one of the first one to show that raw cotton, natural cotton, can be an alternative to synthetic fibers and synthetic materials to protect the environment. So the results keeps on giving, no matter whether you use a crude oil. Now this result is for motor oil, kitchen oil. Imagine that your mom and granny are cooking something in the kitchen. The synthetic fiber will not be able to take the oil immediately. Whereas if you use cotton, unbleached, not treated with alkali cotton, that cotton is very cheap. It creates new product. Now, particularly in Tirupur and other industries are suffering because of lack of export, we could think of developing such new products which are sustainable and that also gives opportunity for export. And I have talked about all this. In conclusion, cotton can find raw cotton with no chemical treatment. Sustainable, naturally friendly, biodegradable raw cotton can find new applications that can go into value added. So this is a value added product. It's not like your undergarment. It's not like your kerchief. It's not like your terry towel. It saves life. So people will be willing to pay money. Governments will be willing to buy it in tons and tons. Advanced textile that can improve lifestyle. Why lifestyle? So nobody wants to live in a place flood with oil, right? That was the reason it created a lot of news when we had these big floods in December in Chennai, where there was leak by one petroleum refinery in North Chennai. So it improves lifestyle, it enhances the health of people, and it also protects the environment. So all this new information, I publish a newsletter called Tech Snips, small articles, not only from my lab. I collect ideas from every place. For example, if Professor El Sayed El Nasher is coming up with some ideas, if he sends it to me, I'll write about it. So it goes to roughly 2,000 people around the world, from Timbuktu to Melbourne to Canada to South Africa. So if anybody is interested, you may contact me by my email s.ramkumar@ttu.edu, and I'll happily include you. And one good thing is you don't have to pay anything. It's free. Particularly, it is useful for young researchers and students if they don't have access to what is going on in other parts of the world, or if they do not have access to getting some papers, my snippets will be able to help. And the very important thing is it's free. Okay, if it's free, it is not costing you anything. With that, I once again thank SSM College of Engineering for inviting me, and particularly to Professor Rajendran for thinking of me, even though it's about 1 o'clock for me, exactly 1 a.m. I'm like a night owl on that. But still, I enjoyed giving presentation. I was told to finish within 25 minutes. I think I did it. If there are any questions, you can ask. And I wish the conference much success. And I also wish all the participants very best in the year ahead. Thank you. Yes. Okay, thank you then. All the best. Thank you.